So, in this video, we're going to use the cosine rule to find the missing side or missing angle of a triangle. This video is split into three parts. Initially, we're going to look at the cosine rule itself and how we can use that to find the missing side. I'm not going to just give you basic examples like this one. We are also going to look at something a bit more advanced like this one here. Then we're going to do the exact same thing, but then find missing angles. And finally, we're going to look at a real exam question to finish off. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause and have a go at the example on the right, which is you do. So before we do start, well, what is the difference between the sine rule and the cosine rule? So if you look at the sine rule first, so now with the sine rule, it's at the bottom there. Don't worry too much about the sine rule itself, like when do you use which one? So if you look at this example up here, it's asking us to find the side. So the first thing you want to do is, does it have an angle opposite it? Yes, it does. Okay. So we could potentially use the sine rule. Now, the only thing we need is there another pair of a side and an angle? So the sine rule is all about opposites. So we have a side with an angle opposite. And on the here, we have a side. Oh, let me just go back. We have a side with an angle opposite. Okay, that means we can use the sine rule here. Now, if you go to the example at the bottom here, now we're looking for an angle. Now, again, it's about opposite using the sine rule. Does it have a side opposite? Yes, it does. Does it have another pair of a side and an angle? Yes, it does. So since we have two pairs of opposites, we can use the sine rule. Now, moving on to the cosine rule. So now, again, you can think of it in the same way. Do we have an angle and a side opposite? Yes, we do. But do we have another pair? No, we don't. We do have this side, but we don't know what the angle here is. And equally speaking, we have this side, but we don't know what the angle here is. So we cannot use the sine rule, okay? So now we can think, okay, what else do I know? Now, this is where the cosine rule comes in. Now, the cosine rule is used when you have two sides and an angle between them, okay? So that's important. So the two sides and an angle between them means you can use the cosine rule. And then when you're looking for, at the bottom case, where you're looking for an angle here, the other time we can use the cosine rule. Again, start the same way. Can you use the sine rule? Well, we have an angle and a side, which is opposite. Good. But do we have another pair? No, we don't. We don't know what this is. And we don't know what this angle is. So we can't use the sine rule. Now, the other time you can use the cosine rule is when you have all three sides of a triangle. Since we have all three sides here, we can use the cosine rule. We have to rearrange this to find the angle. So now that we know when to use what, let's make a start. So again, I want you to think in that same maths way and not memorize formulas necessarily. You will have to memorize the cosine rule and the sine rule because they're not given on the exam. But looking at this, we asked to find the side x. Does it have an angle opposite it? Yes, it does. Now, is there another pair like this? No, there isn't, because we don't know what this angle is, and there isn't a pair for this side and angle. So we can't use the sine rule. So straight away, you should start thinking about the cosine rule, and I've written that down here anyway. Now, what is A? This big A is what you're looking for, is the angle, sorry. So we have an angle here between two sides. That's important, okay? The angle must be between two sides given. And this little a is what we're looking for. So normally the side opposite, well, I say normally, always the side opposite the angle is what we're looking for. That's going to be A, so I've underlined that. So if I write my formula, I'm going to write x squared, which is what we're looking for, is equal to b squared, which is one side, plus c squared, which is the other side, minus 2bc, and then cos A, which is the angle. Okay? It doesn't really matter what you call B and C. It can either be this or this. It doesn't really matter. What's important is that you identify what A is, which is that angle there. Cool. So in this case, if you type that into your calculator, you get x squared as 16.37354 ... You don't want to round at this point because you want to square root that, and then when you round your answer, you get 4.0 centimeters to one decimal place. Now, hopefully you've pressed pause and had a go at the example on the left. So again, hopefully you thought of it the same way. You can't use the sine rule, so you must use the cosine rule. So in this case, x squared is going to equal to the two sides, so 6 squared plus 5 squared minus 2 times 6 times 5, and then cos the angle. And then here we have x squared. If you type that into your calculator, you get x squared equal to 20.08009 ... and square root that to one decimal place is 4.5 centimeters. So now we're looking for an angle at the bottom right, but again, the exact same rules apply. Sorry, we're looking for a side, but the angle is on the bottom right. Does the side have an angle opposite it? Yes, it does. Can we use the sine rule? No. Okay, can we use the cosine rule? Yes, we can, because we have two sides and an angle between them. So we're looking for x, so the cosine rule is going to be x squared is equal to both the sides, so that's 3 squared plus 4 squared, minus 2 times BC, which is both the sides, times the angle, the cos of the angle, and that gives me x squared, and then I'm going to type that into my calculator to get 16.791515 and square root that, and that gives me 4.1 centimeters to 1 decimal place. And again, hopefully you've pressed pause and had to go at the one on the right, so that's going to be x squared is equal to both the sides squared, so that's 6 squared plus 5 squared minus 2 times 6 times 5 times cos 51, and when you get your answer and you square root it, that becomes 4.8 centimeters. So the reason I've put these two examples in is because I don't want you to get used to looking at a triangle in this shape, okay? A triangle can also look like this, and a triangle can also look like this when it's slightly slanted. So again, the exact same rules apply. We are looking for a side. We straight away realize that we can't use the cosine rule. So we're going to use, we can't use the sine rule. So we're going to use the cosine rule. So that then means x squared is equal to one side squared plus the other side squared minus 2 times 3 times 5 times cos of 110. And if you type that into your calculator and square root it, you get your answer as 6.7 centimeters to 1 decimal place. And again, hopefully you pressed pause and had to go at this example. So it's the exact same thing here, 5 squared plus 3 squared minus 2 times 5 times 3 times cos of 72. And when you type that into your calculator and square root it, you should get 5.0 centimeters to 1 decimal place. Now this one, it's not immediately obvious that we need to use the sine or cosine rule here, but if you look at what you've been given, so the question's asking us to find a side, the first thing you want to check is, does it have an angle opposite it? No, it doesn't, but you can find it quite easily because you know angles on a straight line add up to 180. So again, let's ask ourselves that question again. Do we have a missing side with an angle opposite it? Yes, we do. Can we use the sine rule? No, because there's only one pair. This has no pair, and this has no pair. So we can't use the sine rule, we must use the cosine rule. Do we have two sides and an angle between them? Yes, we do. There we go. So now we can just say x squared is equal to both the sides. So that's 7.5 squared plus 8.6 squared times the cos of the angle. And if you type that into your calculator, square root it, you get your answer to 8.1 centimeters to 1 decimal place. And again, hopefully when you looked here, you were like, okay, there's a missing side. It's a non-right angle triangle, so I must use the sine rule or the cosine rule. So does it have an angle opposite it? No, it doesn't. Can I find it? Yes, I can. Angles on a straight line add up to 180, so that must be 70. So we have a missing side with an angle opposite it. Can I use the sine rule? Yes, I can. We have two sides and an angle between them. Again, I know I keep saying this, but it's important that you don't just memorize something and you actually understand in what scenarios you're using what and how you're sort of figuring that out as opposed to just memorizing something and putting it in. Because when you look at the exam question at the end, you'll see why I keep saying it like this. So that will give me 5.6 centimeters once you square root that to 1 decimal place. So here's some questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers, mark your work. So now moving on, we are looking for a missing angle. Now remember what I said earlier. When you have either two sides and an angle between them, you can use the cosine rule. In this case, we don't know the angle between them, or when you have all three sides. So since we have all three sides here, we can use the cosine rule. But we have to rearrange it a bit and put it in this form because we're now looking for an angle. And just to show you how that's rearranged, again, remember, you've got to memorize one of these formulas and then rearrange it in the exam when needed. So the formula you'd probably want to memorize is this one. So a squared is equal to b squared plus c squared minus 2bc cos a. So in this case, we're looking for an angle. So what we want on its own is that there. So if I just take this whole thing and move it to that side, so since it's a negative 2bc cos a, what's the opposite of negative? Positive. So if I move it to the other side, it becomes a squared still stays there, and we have plus 2bc cos a is equal to b squared plus c squared. So that's that done. And now if I move the a to this side, And remember, what we're trying to do here is get the cos A on its own. So that would become b squared plus c squared minus a squared is equal to 2bc cos A. And then finally, since this is being multiplied, if you divide both sides, we can get cos A. Divide both sides by 2bc, we get b squared plus c squared minus a squared all over 2bc. So I just wanted to show you how we actually get to this. So I'm going to rub this off now. So hopefully you can see that's the form that you need the formula in, the cosine rule in order to use it to find an angle. So if I just rub that off now, just nice to know that is. So we are looking for an angle. So let's say that is cos x. And another tip here I want to give is the side opposite the angle is what A is. Okay, that's literally all you need to know. Which way around you write B and C does not matter. So again, B can be any of the other two sides. C can be any of the other two sides. And then now A in this case is the 7 that's opposite it. In this case, it's a bit, we've got 2 7s, so it's not very apparent, but it will be in the next examples. So yeah, once you've got that, again at the bottom, it'll be 6.5 times 7. And then remember, when you do get your answer, you do want to use the inverse of sine. So in this case, we have cos x is equal to 0.2. And then in your calculator, you do x is equal to, you'd write something like that, the inverse of cos. And that gives you 78.5 degrees to 1 decimal place. So press pause and have a go at the example on the right. So remember, the first thing you want to do is, yes, you've got 3 sides and you're looking for a missing angle. So the side opposite the angle is what A is, okay? So we're looking for x. So we're going to say cos x is equal to b squared plus c squared. And that's literally all you need to know in the formula is what A is. And like I said, the other two don't really matter which way around you write them. And when you type that into your calculator and do the inverse of cos, you get 53.1 degrees to 1 decimal place. So moving on, again, we've been given 3 sides and asked to find an angle. The side opposite the angle is 10. That's what A is in the formula. So we have cos x is equal to 4 squared plus 6 squared minus 10 squared all over 2 times BC, which is that. And then when you do the inverse of cos and you solve that, you get 62.3 degrees to 1 decimal place on your calculator. And again, hopefully you press pause and have a go. The first thing you want to do is label the side opposite x. So now you know what A is. And now that you know what A is, you know how to write your formula. So that's going to be 9 squared plus 7 squared. Like I said before, the way you write the 9 and the 7, you can write them either way. B and C is just either this or this. It doesn't really matter which one it is, but it does matter what A is in the formula. That's why I keep underlining it. And for x, that gives me 33.6 degrees. And again, the reason I've included these is to, just so you know that a triangle doesn't always look like 3 sides sort of off the bottom. It can also look like this, and it can also look like this. So again, the exact same thing applies here. Label the side opposite the angle. Now you know what A is in the formula. It makes your life a lot easier to write the formula now. So you're 8 squared plus 5 squared minus 11 squared all over 2 times 8 times 5. And typing that into a calculator is around 13. And also good to sense check it as well. You can see that this angle is an obtuse angle, so it's greater than 90 degrees. And is my answer greater than 90? Yep. So always worth sense checking these as well. So again, hopefully you started with labeling the side opposite the angle, and that is 8. Now you know what A is in the formula, so it makes it really a breeze to write the formula down. That becomes that all over 2 times 4 times 5. And that for x, when you find the inverse, is 125 degrees. So again, looking at examples like we did earlier. So with this, it might not be immediately obvious how you find x, but look, x is on a straight line. So in order to find x, if we can find this angle here, if we can find y, all we need to do is subtract 280 from y. So now if you look at it, you've got a triangle with 3 sides and you're looking for an angle. We can use the cosine rule. So we can just say cos y is, again, label the side opposite the angle. That is what A is in the formula. And for y, that gives me 53.7519, ... And now I'm just going to subtract that from 180 because angles on a straight line add up to 180. and that gives me 126.2 degrees to one decimal place. So again, when you look at this one, you're trying to find x. X is an angle in a straight line. So if you find y first, if you find y first, you will get x by subtracting 180. Now that's the side opposite. Again, write the formula. No, it's not x, it is y. Y is what we're finding first, so that is going to be 4 squared plus 5.4 squared minus a, which is what I've underlined, all over 2 times 4 times 5.4. And that gives me y as 76.138. Again, you don't want to round at this stage. Subtract that from 180. So x is going to be 180, take away y, which is 76. And that gives me, 76 with all the decimals at the end. That gives me 103.9 to one decimal place. Here are some questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers. Mark your work. Now, this is where we have an exam question. And this is where that thinking really kicks in that I was talking about earlier. So what is the question asking us for? AD. Okay, let's label that. AD is that side there. Okay, so let's label that X. Now, the way I always think about it is we have this side. Is there an angle opposite it? Yes, there is. Awesome. That means we could use the sine rule if there's another pair. So what else do we know about this triangle here? Okay, we know that there's a pair here. Is there another pair? No, there isn't, because we know that side, but we don't know this angle. Is it easy to find this angle? No, it doesn't look like it, because we don't know what this angle here is. Okay, so then the next thing you ask yourself is, can I use the cosine rule? Well, I have an angle, and I have one side, but I don't have both sides. So if I had this side, I would be able to use the cosine rule. So immediately, you should start thinking, oh, so if I find BD, let's label that y. If I find what BD is, I can solve the question using the cosine rule. So then you can look at the bottom triangle here, and you can start to think, okay, I've got y. Is there an angle opposite y? Yes, there is. Can I use the cosine rule if I have another pair? Well, I do. I've got this side and this angle. So since I've got two pairs, I can now use the cosine rule to find y. So the way we write that is, because we're looking for a side, we're going to write side over the sine of the angle opposite the side. So that's going to be sine 34. And again, another side, which is 12.5, with the sine of the angle opposite the side. There we go. And now we can solve y. We can rearrange that, and we know that sine 34 times 12.5 over sine 109 is equal to y. And that gives me y as 7.392674 ... Again, on your calculator, you can, it'll just be saved in the answer button. So that's y, but that's not what the question asked for, right? We're looking for x. And now if we go back, now that we know what y is, we have this. So we have two sides and the angle between them, and we can use that using the cosine rule to find x. So we have x squared is equal to b squared, which is 11.4 squared, plus c squared. In that case, that's just going to be y. So I'm just going to write 7.39 ... squared. And obviously on your calculator, you can just use, like I said, the answer button. You can just use answer squared. Minus 2bc, so that's 11.4 times 7.39 ... times cos of the angle, which is 86. And if you type that into your calculator, you get a value for x squared as 172.8539. And if you square root that, you get 13.1 centimeters to 3 significant figures. So, thank you so much for watching. If you found that video useful, please consider subscribing. And as always, I'll catch you in the next one.